So there are three types of asymptotic notations. The first one is big O notation, the second one is big omega, and the third one is theta notation. So now let's talk about big O notation. So big O notation is generally used to represent the upper bound. So it is used for worst case complexity algorithms. So let's say the definition of big O notation. A function f of n is said to be in O of g of n, denoted by f of n belongs to O of g of n, if there exists a positive constant c and some k greater than equals to n such that f of n is less than equals to c into g of n for all n greater than equals to k. So let's understand what this is. So this is the graph of big O notation. So it represents the upper bound which is c into g of n, and f of n is given by the order of g of n, which is O of g of n. So for all f of n, g of n is always greater than equals to f of n, where c is a constant which is greater than 0, and n is always greater than equals to k. In this graph, here the x-axis represents the input where it is n, and the y-axis is the time is given by the y-axis. So let's understand this by an example. So let's take f of n as 2n square plus n. So for by in big O notation, we write it as 2n square plus n is less than equals to c dot g of n square. Here we have taken n square as this big O notation represents the upper bound. So in 2n square plus n, the upper bound is n square, which one is bigger? Compared to n square is bigger, which is quadratic. So we have taken as g of n square. So let's take it as n square. 2n square plus n is less than equals to this 3n square. We have took it as 3n square as the f of n should be less than or equals to g of n. If we take any number less than 3, it will become reverse. So we have taken 3n square. So upon solving it, we get n less than equals to n square. But upon dividing the both sides by n, we get 1 less than equals to n, which is n greater than equals to 1. So for all the values of n greater than equals to 1, this represents the upper bound c into g of n, and f of n is always less than c into g of n. So so for all the values n greater than equals to 1, this condition holds good. So this is big O notation.
Hello everyone, my name is Sushrita. I am going to explain the second type of asymptotic notation, that is big omega. So big omega is represented by the symbol, and this is the representative symbol, and it is also called as lower bound. So before going to the technical representation, I am going to explain the definition of big omega. So big omega is the minimum amount of time taken for an algorithm for the execution, that is called as big omega. So this is the graphical representation where the first line indicates the f of n represent units, and the second line c dot g of n, and this is also called as lower bound. Between these two lines, their intersection point occurs, that is called as n naught. So this is the mathematical representation. F of n is equal to omega g of n, and f of n is greater than c dot g of n, where for every n is greater than or equal to n naught, where c is the constant and n naught is the positive integer.